In this video, we will design the networking and compute infrastructure of a serverless application on AWS. Hi everyone, Yvonne here with another episode of DevWidgets. In this video, we will be designing the infrastructure of our serverless microservice that will be backed by Amazon DynamoDB. If you want to understand how we came about choosing DynamoDB to be our database, click on the link now. All right, so quick refresher. Our business use case is that we're creating a REST API that returns a list of upcoming events. Here are the APIs that we are going to support. We saw in the last video where our data was going to be stored. Now we need to decide where we're going to run our code and how are our clients going to be able to access that code. So when we talk about compute and serverless from an AWS perspective, AWS Lambda is usually the first thing that comes to mind. If you need a bit more control of the underlying infrastructure and an order of effort, the next thing you might do is containers, then maybe Elastic Beanstalk, if all else fails, EC2 instances, and then God forbid bare metal. In my personal opinion, you should always start with AWS Lambda behind endpoints so that you can move if you need to. This way, if there's any issue, you find that Lambda is not working out for you, you can make a quick switch, and with relatively very little downtime, your end users would then be routed to a container, for example, or an EC2 instance. In our example, we're going to use AWS Lambda. And for the endpoints, we're going to use Amazon API Gateway to achieve that abstraction together with Route 53, and then to allow our end users to be able to make RESTful API calls to our microservice. So let's draw that out and see what that would look like. I'm going to put this to the side, get a blank piece of paper. And so, as always, we have our end users, right? They are why we do what we do. And so our end users could, for example, be using a laptop or a computer. Everybody seems to be using iPads or laptops these days. Or a device, or phone, iPad, right? And so they make calls, RESTful calls, to some sort of endpoint. And so as I mentioned already, I'm going to use API Gateway, right? So let's label that out. So API Gateway. And then in API Gateway, there are a couple features that we're going to use. Like I mentioned, we want to use endpoints, right? And we want to be able to have that flexibility to move what's behind that endpoint with whatever whim we may have or backed by data. So the first thing is our domain, right? So let's say we're going to use https://api.devwidgets.com. So how do we achieve that, right? So this is going to use a domain that we have in Route 53, for example. And that's AWS's DNS service. Oops. And then the next thing we have is, for example, this event. So this represents our microservice, right? And so to do that, we use base path mapping. So API Gateway, we say for this API, please use this custom domain. Then we say anything that has /event, take it to our integration. So in this case, that integration is going to be Lambda. But then let's be a little more specific. So we also have to define what APIs to send to our Lambda, right? So in this case, for example, events, then there's the /IDs, so on and so forth, right? So for this, I can use a proxy and just have it send everything after events, everything go directly to my compute layer. So in our case, our compute layer is AWS Lambda. And so for AWS Lambda, there are two levers that we really have, the key there. There is the language that we use, and then there's memory. And depending on like the memory that you choose, where you are, that decides, what kind of CPU, virtual CPUs you get. Do you get one? Do you get two? Do you get, I think today it's up to 6. And then a couple considerations that you need to take into account with AWS Lambda. It has an execution time of 15 minutes. To be able to call our different GET APIs here, 15 minutes is more than enough. And if any REST API takes more than a minute, or well, actually, it can be longer than 30 seconds because we are using API Gateway. But your GET APIs shouldn't be taking more than a second, honestly. So that you have quite a bit of buffer there between 1 second and let's say 30 seconds on API Gateway. And you're definitely not going to come close to that 15 minutes on AWS Lambda. Obviously, for other workloads, that's important. For GET REST APIs, that is definitely not something we're going to have a problem with. So I'm going to start small. Honestly, I think this is going to be a very thin client, and I'm going to just start with 512 MBs. And then for language, I'm going to do Java. There are quite a number of different languages that you can do, and you can also use containers on Lambda to be able to do any custom language that they might not support out of the box. But my strong suit is Java. Honestly, it's probably better for startup time and other reasons to use maybe something like Node or Rust, etc. But we're going to start this one. We're going to do this one in Java, and then maybe in the future we might have a series or two that uses another language. So like we made the decision in our last video, our Lambda, pretty thin client, it's gonna go get details from our database and then return it to the front end. And honestly, that is pretty much it. We don't have to concern ourselves with the VPC or network or CIDR blocks or anything like that because we're using managed services here. API Gateway takes care of everything. It takes care of routing our request directly to our Lambda, and then Lambda then responds to API Gateway, and then API Gateway returns that response to our front-end users. So that's basically it. That is our infrastructure in a box. If you, again, are enjoying these videos, these series, you can go back and check out any of the other previous videos. If you have any questions, let me know. Please like, subscribe, share if you think this might be helpful for somebody else. Thank you so much for spending this time with me. Most importantly, happy coding.